Let's now do an example of microstrip design. The problem statement here is pretty simplistic. We want to design a 50 ohm characteristic impedance microstrip trace, and the material we have to use is a 60 mil thick FR4. So the first step is to determine what the effective electric permittivity is for the material, and we would get that information from the data sheet. For FR4, I gave you some numbers in the beginning of this lecture that different FR4s, it's a fiberglass material. It's got a relative permittivity between 4 and 5. So you'd get this exact number from the data sheet, but I'm going to just use 4.5 for this example. So step one, get that information. The 60 mil is also usually found in the data sheet for the material. So that would also probably come from the data sheet. Step two is to determine whether we're in the low impedance or the high impedance design regime using the microstrip design chart. So we're going to go to that microstrip design chart that I showed you. Remember, the first thing you do is you find your characteristic impedance on the vertical axis here. So we're wanting to design 50 ohms. So just draw your line straight across here. Okay, and then what you need to do is you need to find the intersection of your electric permittivity of the material with that 50 ohm line here. And you'll see that this chart doesn't have a 4.5 line on it. It's got a 4 and a 5 line. So what we'll do is we'll trace the 5, and 5 seems to intersect, let's see, 5 intersects with 50 ohms, roughly right there. And 4 intersects with 50 ohms roughly right there. So let's see, 1.5. I'm doing a little estimating here, but it looks like for 5 we've got a value of about 1.7, and for permittivity of 4 we've got a value of about 2.05, somewhere around there. So 4.5 would be halfway between those two. So if we do linear interpolation, you would get a value of 4.5. The W to H ratio is going to equal about 1.875 from this chart, which puts us kind of on the edge, but in the high impedance region. So we need to use the high impedance design equations. So now we return. So the design equation for the high impedance region is, first we calculate this value called A, and it is equal to our desired characteristic impedance divided by 60 times the square root of the actual permittivity of the material of the substrate plus 1 divided by 2 plus epsilon r minus 1 over epsilon r plus 1, and we multiply that by 0.23 plus 0.11 divided by epsilon sub r. So that's our equation that we're working with. So A is going to be 50 ohms divided by 60 times the square root of 4.5 plus 1 over 2 plus 4.5 minus 1. We need to divide that by 4.5 plus 1 and multiply that by 0.23 plus 0.11 over 4.5. And that gives us a value of A of 1.516. We can now calculate the W to H ratio necessary for a 50 ohm T line as 8 times the natural number E raised to A divided by E raised to the 2A minus 2. So that's 8e to the 1.516 divided by e to the 2 times 1.516 minus 2. And we carry out that fraction and we get an answer of 1.94 as our W to H ratio. H comes from the circuit board. That's a fixed number. So we'll see that W is just equal to W divided by H times H, so that's 1.94 times 60 mil. And that gives us 116.4 mil. And remember, a mil is just 1,000th of an inch, so I've specified this in 1/1000th of an inch.